Good afternoon, good morning, good evening. It's Sunny Patel here again from Open Connections, here to present to you about Open Connections Text Analytics Solution. This is the second recording. The first one, there's a web link there which goes into a bit more detail about OCTAS for healthcare, our solution to help improve the quality of NHS data and the access to it. So what is OCTAS for healthcare and what are the challenges that NHS Trust have? So from our understanding, working with the NHS Trust, they have multiple systems that have a load of unstructured content. Unstructured content could be letters, clinicians' letters, free text information captured into radiology reports, pathology reports, electronic patient record systems for handover. One of the biggest challenges NHS Trust is the explosion of data and the access to it. What they want to try and pull out, so this is clinicians as well as clinical coders, key information to do with the patient, whether it's medical data, diseases, symptoms. All this information is potentially held within electronic systems, but maybe within multiple systems. What OCTAS for healthcare does is effectively integrates all those by bringing it back together into one clean UI. So what I want to show you today is actually the solution itself. This is just a web page showing you effectively the login screen for OCTAS for healthcare. The secure username and password you'd require to log in, and it's simply accessible by a browser for the NHS Trust. So once you've logged into OCTAS for healthcare, what you clearly see is the ability to search for a patient. So immediately a clinical coder, for example, could type in a patient ID number. We're just going to use 5 in this case, and clearly this is a demo environment with dummy data. But if you typed in a patient ID, very quickly you would pull out the relevant information for the patient. In this example, you can see the forename, the surname, Marty McFly, and the date of birth. Someone in the office likes Back to the Future, hence Marty McFly. What you've got here really is the idea, once you've typed in that relevant information, as I said, you've got the spell information, so you'll have a spell number, you'll have a start date and an end date for the spell. And what start date and end date is, so if a patient is admitted into hospital, from the day they're admitted to the day they're discharged, that's the start date and an end date. And as you can appreciate, some patients may be visiting the hospitals more often, and therefore you could have patients with a larger list of spell IDs. But in this dummy example, we've just got a patient that's been in there once, between those dates of 30th of August and 6th of November 2014. So we click onto the spell ID. Clearly what we show here is the ability to pull in the rich information that I was just talking about. So within the NHS Trust, there's a lot of free text information, whether it's captured on letters, electronic patient record systems, their EPR systems, or other clinical systems. One of the challenges is having to log into multiple systems. This is showing one clear way of being able to have the solution do the integration piece between all the different data sources, and then show the relevant information accurately and quickly to, in this case, clinical coders. And so here we have different tabs. You've got a tab here that says diagnosis, you've got one that says procedures, medicines, instructions, and history. If I just click on history, for example, to show you some of the stuff that we're doing, here you can see what the actual system has found. So it says it's taxonomized it as staff aware. Over here you've got a text column where actually the free text data is. And if you right click on there and press view full entry, what you see is the actual source of where that data was. So in this example, the source of the data comes from a field known as situation, in this case from an electronic patient record system, and it says known to heart failure. So simply what the solution is doing is using its clever natural language processing capability to understand the free text and then convert it to a field known as what it's found. And also what you can see here are different tabs. So this data has come from a patient's episode within that spell, and there could be other information as well within that episode. So I'm clicking away the different tabs on the top. What the solution could be evolved to do for other organizations is, instead of it saying situation, medical recommendations, etc., you could clearly have another tab here for plugging into discharge summary, operational letters, surgical post-operative letters, radiology reports, any other clinical systems where the data is electronic. This system could be effectively pulling into it. So OCTAS for healthcare could be pulling that rich data out and effectively improving the quality of the data and the access to it. So if I go back here just to show you how it can help with clinical coding, clicking on diagnosis is what I just did there. And if we just scroll down, you can see a list of diagnoses found by the actual solution itself, as well as the free text information from where it was actually sourced. So these are like snippets of the data. If I right-click again and show a full entry of another one here, what you can see is from here, this data has now come from the background assessment for the episode for that patient. And typically what you've got is there, it's pulled out CVA and effectively it's codified it there as what is found it out. One other thing that you can do with the solution is for the clinical coders, it can actually help suggest clinical codes. Now we're working with many other trusts at the moment, and clearly what we're trying to do here is to produce a system that can go to the next level of being able to suggest codes for trainee clinical coders. So the idea here is that as the system is used more and more by different organizations, when you have this information known as smoker, let's say, what you could do is right-click onto here and choose a code. So you could assign a code for smoker. So if we say F17.1 as an example, so I'm suggesting that is the code for a smoker. What that does is that patient's episode is now being coded as a suggested F17.1. And if you right-click on there, what you can do is actually then choose the recommended code and effectively rubber stamp it. So here now it's been selected, and as you can see, it's just popped up into the selected code. Over time, what would happen is that the solution being used by multiple clinical coders coding it, the actual system would learn that as the relevant information is found, it would start coming up with a list of suggested codes. And then it's up to the clinical coders to actually select it and effectively rubber stamp that data. Now, the clever thing here is that it's actually not just looking for keywords. So it's not just looking for the word smokes or smoker. It understands the difference between the patient is a smoker, was a smoker, used to smoke, or in this case, if we right-click, smokes 1 pack a day. So it's clever enough to understand that from the statements here in the background, it's stating that the patient smokes 1 pack a day, meaning the patient's a smoker. And that's clearly what the solution is doing. So it's using this text analytics capability, natural language processing to pull out rich information and present that to clinical coders and help them speed up the clinical coding process. Similarly, as I said, we've got procedures here. And once again, as you can see, you've got all the information that's found on the left-hand side as what it's been taxonomized. You've got a list of free text snippets there. And then you've got some dates, and as you can see, the dates here could be of different dates when different procedures are actually being taking place, etc. If we just right-click here, just to give you an example of bringing that data again, you've got ECG done on the 13th of September. And that's clearly what it's doing. So it's pulling in the rich data from multiple sources, and that's really what I wanted to show you in terms of the demonstration and the look and feel of how it works. One final thing just to basically tell you, so pulling in rich data from unstructured content. Clinicians, especially at this present time, are overwhelmed with regards to their workloads. They have an exponential amount of data available to them, but only a finite amount of time to treat patients. What the system here is to do is to actually help speed up clinical coding. However, a later phase of this solution, a phase 2 should we say, could also then use that rich data once we've selected and rubber stamp the data to actually bring rich insights for clinicians at the point of care. So what could happen is you could have rich information like this extract of a medical record, being able to pull out symptoms, findings, family history, and key other information that could be presented to a clinician, which obviously would be very powerful at the point of care. Some of the challenges with regards to developing this innovative solution was obviously the natural language itself is quite hard. We have misspellings of the word diabetes, for example. You've got acronyms that are used within the NHS Trust. There's simply a rotation every 6 months or so within the NHS Trust, which comes with its own new slang of medical terminology. And keeping up with that is partly what our solution is doing with us working with the clinicians. But as you can see, is we have the challenge to actually be able to identify the misspellings to be able to then extract the relevant data itself. And at the present time, the way the solution works is it actually has a number of acronyms that it pulls out, a number of key diagnosis procedures and high-cost drugs. And the benefits to the trust itself are multiple. One of them being is the saving of time and money when conducting the clinical coding process. That's generally a manual process. Clinical coders are experts in their own field, but one of their challenges is that 75% of their time is spent looking for information. And then they actually end up coding the information from their knowledge using either ICD-10 books, if it's a diagnosis, or OPCS, which is to do with procedural information. And so improving the quality of clinical coding is clearly one of the things our solution does, because it's able to present key information to them at the point of clinical coding. So reducing the clinical coding error rates. Furthermore, there's a shortage of clinical coders within the UK. What our solution is able to do is to help the actual clinical coding managers manage and performance manage the team by being able to do some sort of audits as well. And we're talking to a number of other trusts as well, where they're actually looking to use the solution, not just from a clinical coding perspective, but actually to identify patient cohorts for clinical trials. So a lot of university hospitals are certainly looking at ways to improve the ability to pull out patient cohorts. If you're relying solely on the clinical codes itself and you had an error, you could be missing out on a certain amount of patients. The future for this solution and where it could go further is obviously using this as a base foundation to not just extract key insights, but to then trigger those for predictive decision support for clinicians. I don't think we're going to get to a stage where you're not going to need a doctor, but you're certainly going to get to a stage where a trainee doctor could be presented with a list of key ideas from pulling in rich symptoms, diagnoses, and then actually suggesting what the diagnosis could be using predictive decision support capability. And that's later down the phase, I think. But the idea here today was to really give you an idea of OCTAS for healthcare, an innovative solution in the UK space, also looking to spread out elsewhere, providing rich information to NHS Trust and improving the quality of the data as well as the access to it. Thanks a lot for your time today. Contact details are on the page now. Should you have any further questions, please do not hesitate to contact us and have a good day. Many thanks.